Hello dear students, another lesson about the capacitors and dielectrics. So this is the dielectrics. Okay, topic number 5, chapter number 24. Okay, so dielectrics are basically any insulators or any insulator that is present between the plates of a capacitor. Insulator insulating medium or material present between plates of capacitor is called dielectric. And why we use dielectrics? Because the capacitance, our ability to store capacitance, depends on the dielectric medium. The stronger the insulator, stronger this medium dielectric, stronger will be the capacitance, the more will be the capacitance. The ability to store capacitance, the ability to store charge depends on the dielectric medium basically. Okay, so if the original capacitance is C naught, so that it is experimentally observed that when we place any dielectric medium between the plates, so that the capacitance is increased by a factor of K, because where K is the constant for that medium, that constant is called dielectric constant, that is represented by K. So that the if for example C is equal to epsilon naught A over D, this is formula for capacitance of parallel plate capacitor. So this is formula for when there is no medium between the plates. There is no medium between the plates, the empty space between the plates. So this is formula. Epsilon naught is the constant for free space, but when we insert any medium between the plates, so that this formula can be modified as this formula, we can rewrite this equation. For example, if we place any other medium, any insulating sheet between the plates, this insulating sheet is known as dielectric. This insulating sheet is known as the dielectric, and this medium has a constant. This constant is known as dielectric constant, that is represented by K. Now the modified formula for this is C is equal to K epsilon naught A divided by D. So this is, if we say this is C naught, original capacitance or starting capacitance or initial capacitance, if C is the capacitance when we insert any medium that has dielectric of coefficient or constant K, and C is equal to K epsilon naught over D. So if I use equation 1, so this term in the bracket is actually original C naught. So it means the capacitance with the dielectric medium is equal to K multiplied by, so it means the C is greater than C naught, mean that capacitance for dielectric medium has increased by the factor of K. So the capacitance increases when we insert any insulating sheet between the plates of a parallel plate capacitors. So I explain in detail why why this happens. Okay, why the ability to store charge increases by inserting this into the by inserting the medium into the plates. Okay, so the formula for new formula, we can also write this equation C is equal to K epsilon naught. We can also write C is equal to epsilon naught A over D, because if we replace E naught K is with the E, that is the modified permittivity, that is the product of E naught and K. So then we can also write C is equal to E over D. This is the capacitance for modified capacitance for the dielectric medium between the plates. So that the energy stored can also be changed by using this formula. So energy density is known as half epsilon naught E square. So energy density also modified half K epsilon naught E square, so that the modified energy is half E into E square. So that it means the energy density increase if we place any dielectric medium between the plates. Okay, now we further discuss that there are two experiments in figure 15. There are two experiments that one if voltage held constant, and the second one is the charge held constant. If we kept the voltage constant, and we connect a capacitor with the voltage, and the original capacitance is C naught is equal to Q over V naught. This is the original formula for capacitance. But when we insert a dielectric medium between the plates, so the modified formula is C is equal to K C naught. You can see that C is equal to Q over V naught. So because we know that when we place a dielectric medium, so the ability to store charge increases. So the Q increases to K naught, Q increases to K into Q naught, because it is experimentally found that the more charge is stored when we place a dielectric medium between the plates. So if we put Q is equal to K Q naught, so that the modified equation for Q is equal to K Q naught, so we are left C is equal to K C naught. So this is, again we can see that the capacitance with the medium is greater than the capacitance without medium, C is equal to C naught. So if we in the experiment 2, for example, if we had the charge constant, if we do not change the charge constant, if we do not change the charge, so the same result we obtain, the C is equal to K C naught. The capacitance is greater than the capacitance with the dielectric medium is greater than the original capacitance. So if capacitance is greater than the original capacitance, if we insert a medium, now electric field intensity, what about electric field intensity? So the electric field intensity should reduce. So original intensity E naught is V naught over D. This is when no medium is present between the plates. So when we place a medium that is dielectric medium, so intensity ED is equal to V over D. The formula is modified formula. So we know that V is equal to V naught over K. V is equal to V naught over K. So if we put equation number 1, equation number 2, so if we put value of V is equal to V naught over K in equation 2, so we get ED is equal to, so I have to write here ED is equal to instead of V, we can put V naught over K into D. So V naught over D is the original intensity E naught. So E naught over K. So you can see that in intensity for the dielectric medium has reduced by the factor of K, because K is dividing here. K divides, so it means the ED is less than the E naught. So that the intensity with the dielectric medium is less than the original intensity, so that intensity reduces. So intensity reduces, that's why the charge leakage is overcome. So that's why the capacitors stores charge for the longer time. So the ability of a capacitor to store charge increases. So if I summarize, when we place a dielectric medium, so the capacitance increases by factor K, charge increases by factor K, capacitance increases by factor K, intensity reduces by factor K. Okay, thank you.